All right, so this problem says for the function y is equal to f of x is equal to x squared minus 4x, where x is greater than or equal to 2, find the derivative of the inverse function at 5. So in general, when you're trying to find the derivative of the inverse function at a particular a value, you can use the formula of the inverse function derivative at a is equal to 1 over the derivative of the inverse at a. So I know there's a lot going on with that function or with that formula there, but let's start from the inside out. So let's start with what would be the inverse at a. So the inverse function, remember that the inverse function, it is where all of the x values and the y values have switched from the original function. So to find the inverse function at a particular a value, we could try to directly find the inverse function. This one would take a little bit of complex manipulation because we'd have to complete the square and etc. So instead of doing that, if we plug in our 5 for y, then we know that if we solve our inverse function, if we say we have some value of x when y is equal to 5 for the original function, then the inverse function would be that value of y would be then the value of x, and we would find the y for it, which would be the function value. So what we're doing is we're plugging in 5 for y into our function. So if we have 5 is equal to x squared minus 4x, we need to solve this for x. So let's subtract 5 on both sides. And that'll give us 0 is equal to x squared minus 4x minus 5. So now we have a quadratic. And to solve a quadratic, we can look for two numbers that multiply to get -5 and add to get -4. That would be -5, -5, and +1. So we can factor this into x minus 5 and x plus 1 equals 0. So if we set each of these equal to 0 separately, we get x minus 5 is equal to 0 and x plus 1 is equal to 0. So x is equal to 5 and x is equal to -1. So we have two possibilities for x that when x is equal to either 5 or -1, that the y value would be equal to 5. However, we are given this domain that our x is only greater than or equal to 2. So we can ignore this x value, and we know that our x value is 5. So that means when y is 5, x is 5 in the original function. So in the inverse function, when x is 5, y is also 5. Okay, so we found that our inverse function, when x is 5, that y would also be 5. Okay, so let me erase a little bit of this to give myself some room. Okay, so since we know that the inverse at 5 is equal to 5, we can plug that into our function here. If we say the derivative of the inverse function at 5 is equal to 1 over the derivative at, and f inverse of 5 is 5. So we're looking for 1 over the derivative at 5. So let's next find the derivative. I'll come up here to do that. The derivative of this function, if we use the power rule, we'll bring the 2 down to the front. 2x, subtract 1 from the exponent to make it just a 1. And then minus 4, then the x just drops off because we're bringing down the 1. Okay, so this is my derivative function, and we need to find that at 5. So if we plug in 5 for x, we get 2 times 5 minus 4, and 2 times 5 is 10, minus 4 is 6. So f prime of 5 is equal to 6. So let's substitute, instead of f prime of 5, we'll sub in for 6, and that makes 1 over 6, and that is our answer. So I know these are a bit tricky using this formula because it's a bit of a bear kind of formula, but if you start from the inside and work your way out and substitute as you go along, then I think that helps to simplify it down a bit. Okay, so I hope this was helpful for you. And if it was, please like and share with anybody who you think would benefit from these videos. Thanks so much.